And we're live. Hi, everyone. Okay, we can see everybody coming in. Okay, this is going to be a really big one. You guys are popular. This is fantastic. Thank you so much for joining us today. Welcome, everybody. For those of you who are live with us on Zoom, it is 9 a.m. here in Sydney, Australia. So if you're joining us via Zoom, do say hi in the chat. Good to know who's here, who we've got joining us. Fantastic. Good to see you all here. If you have any comments you'd like to contribute to what the guys are saying as we go through it today. Oh, hi everybody. Fantastic. Just say hi in the chat. If you have a particular question though, as they're talking, do pop that in the Q&A and we are going to address those questions at the end of the session. So let's get started. So welcome. My name is Danielle Stein-Fairhurst. I'm a financial modelling specialist, and my job whenever we run these virtual meetups is to bring you speakers who are relevant and the topics that are relevant to the world of financial modelling, and data science is a really, really popular topic at the moment. It is the sexy new job of this of the modern age. Now, Jordan Goldmeier is somebody who I've known for a very long time. He is fantastic to follow on social media. He's always coming up with really interesting, new, different things. I first met Jordan, he probably doesn't remember this, but when I was at the PASS conference in San Jose. How long ago? That was about five years ago.
I think so. I do remember that. I remember that.
Yeah,
I think that was
you
like
were
in 2000. Sorry.
Yeah, you were the keynote speaker, I think.
Was I? No, I don't think I was the keynote at that. I do think I spoke though, but it would be nice if I was the keynote. I do remember meeting you. It was really cool to see you and all the other people in the Excel community who I had met virtually over the years.
Yeah, and things have come a long way since then, particularly virtually. And then after that, it was this is reminding us of the Excel TV days when I was one of the guests on there. So Jordan has recently written a book together with his co-author Alex Gutman. So they're both going to be speaking to us today about their new book and about data science in general. So Alex is a data scientist working in the industry. Their book, Becoming a Data Head, is about how to think, speak, and understand data science. Also, Jordan's got a new course coming out as well, which I think he'll tell us about at the end. I think that was all I needed to mention to you. So I'll hand over to the guys and to tell us all about it.
Sure. We'll do a brief introduction. As you heard, I'm an Excel MVP. I've written a few books on Excel, but I really cut my teeth on this stuff in Dayton, Ohio, and that's where I actually met Alex way back even before the Excel TV days when I was just learning how to do this kind of work. So, Alex and I would kind of practice explaining how these different topics. We'd kind of practice explaining how we can make it easier for people who didn't quite get it to understand. And that's really where this book was born, like 10 years ago. So, it really was like I would say it was just like really kind of like a long project until we decided to do the book. So I think I've talked enough, so I'll hand it over to Alex to introduce himself.
Yeah, thanks, Jordan. Thanks, Danielle. So my name's Alex Gutman, and I'm a data scientist working in industry. I've worked for Procter & Gamble as a statistician, and that became a data scientist, and then also for a company owned by Kroger in the US, a large grocery chain, where I was a data scientist. So I have a lot of practical machine learning, statistics experience. And what really kind of lit the fire where I connected Jordan, where, hey, I think we need to get this book done, is that I was doing a lot of training because I work with a lot of data scientists, but we also work with our business partners and managers. And there was always this disconnect and miscommunication where we're doing all this great stuff and sometimes it's misrepresented or not understood. So the idea, I started teaching this class at work is, how can I demystify this? Jordan and I were talking about it because it was rekindling our conversations at the Air Force. And I often say the audience for this book, and shameless plug here, I'll hold it up, is for people who work with people like me and Jordan, someone who they've heard the hype about data science, machine learning, AI, whatever term you want to call it, but they're like, I need a solid understanding. I want to know what questions to ask, cut through the hype, tell me what I need to know to be effective in this space. So that was the motivation for the book, and also where we're going to pull a lot of the content from that we'll be presenting to you shortly.
All right, and so with that, what I'm going to do is I'm going to go ahead and share my screen. So everyone, if you just give me 1 second. So we have some great content for you today. We're going to talk about becoming a killer analyst, data critical thinking skills for financial modelers. Okay, so I wouldn't say that in my career I was always a financial modeler. I definitely did financial modeling quite a bit, and I met a lot of people who would be, financial modelers full time. And I think what's most interesting to me is that many of them, if you ask them, are you doing data science? Some of them would say, yeah, I think so. I'm running these statistical analyses, I'm doing time series, but I can't get the other people who call themselves data scientists to really, see that. And I think in other cases, you might meet financial modelers who say, well, our company keeps calling it data science, but we could be doing so much more. So, in many ways, cutting through that noise and understanding, what does the data actually say? These are the skills that we want to impart. And we do take, we do have a big amount of this from our book, Becoming a Data Head. So if you were wondering where can you learn more about this content, definitely check out our book. And so, in thinking about this sort of confusion, right, around data and data science, we came up with this term, the data head. And the data head is an active participant in data discussion. So if you're someone who works in finance, that's probably either someone you aspire to be or already are, right, in some ways, right? So you're someone who loves data. And so it's not hard for you to become an active participant. But what we really want to clarify here is that, it's not all I would say just enthusiasm about data, but being an active participant means understanding what the data really says. We say data literate, and I say this, I said this in another talk, so I have to admit this here, that we're not all quite sure what data literacy means, of course, right? So I still feel like the industry is figuring that out, but I do think the concepts that we describe would fit under that category of people who know how to work with data, and in particular, having a critical understanding of the data. But that is not enough. So we also describe thinking statistically and avoiding the common pitfalls that you might see. And so before I go on, just in thinking, we don't have a whole lot in this talk about this, but I did do a talk recently, and it is in the book. We talk about the concept of a data disaster, and there's multiple data disasters, I would say, throughout history, or at least recent history. I think that one of those examples is the failure of our ability to model those mortgage-backed securities during the Great Recession. So, in many cases, we look at things like recessions. Obviously, there's a lot of pieces behind that, but I think the piece that I want to focus on in terms of this talk is that there were modelers who really made the incorrect assumptions about their models, right? So they had an assumption that defaults would be an independent event and not conditional on other defaults, and so they were inevitably wrong about that, right? But I think really what we want to hone in here is that, it's easy to look at that story and say, well, why don't we just be right about it? Why don't we just think differently? But the people in these cases, right, were actually very smart, intelligent people. Even though this was the days before the boot camps and the data science certificates, they were still the people who would be, or at least lay the groundwork for the job title that we would call a data scientist, right? So they were quants, I think is what we would call them. So it's not really just a matter of learning all this stuff, but it's also a matter of communicating it and understanding why these projects fail. So that's kind of me on my soapbox, just to really open your minds to the idea of what we mean by a data head. It's not, someone who gets a master's degree in data science, because anyone could be a data head. So part of this is thinking statistically. We have this quote here about statistical thinking is about being part detective. It really is all about turning on that critical thinking brain. And so to do that, you have to ask good questions, understand variation. We'll talk about that in a second. And I love this, the illusion of quantification. So we talk about this briefly in this book, and I have to admit that I had heard it before from someone in academia, and he described the illusion of quantification as the pursuit of driving metrics without a clear statistical foundation around what they mean. And if you work out in a corporate environment, you have seen this sort of illusion of quantification. So it's very important, of course, that the work that you do can be traced to some real actionable result. Or as today, the big thing right now is to trace all your data science work to ROI, which is not a bad idea. I just don't want us to get hung up on that being the only outcome that really matters. So as I said, we'll return to this idea of variation, right? And at its most basic, right, variation really means that you understand the universe as being, as things change all the time. So, some of this variation we're really used to. The electric bill, the time you get up in the mornings, not always on the dot the same thing. Temperature, tire pressure, maybe if you check the scale throughout the day, you would be surprised or dismayed or happy, perhaps, at the time you checked it, right? So we understand that variation is part of the universe. We understand that it exists. And I think that many statisticians learn about this, and many people learn about this in their undergrad, but it doesn't really get applied when we do data science projects. So consider this here, right? So we have a little scenario for you. And I don't have the chat up. Let me see if I can pull up the chat real quick in case anyone's asking questions.
Nothing yet. Yeah, but do put any questions in the chat or in the Q&A as we go.
So, you're the manager of a retailer, right? So, I don't want to read this whole thing to you here because, I think you get the gist of it here, right? So the basic thing is you run lots of surveys during the year. Corporate only wants 9s and 10s, right? So anything less than that is not as good. So what happens is we have the results, okay? And so you can see here that it's bouncing around our target. Now, this type of chart you might see in a corporate environment. It would be very easy. I don't have my pen hooked up, so I'm just going to use this thing here, right? So management thinks that they're doing interventions here as they look at this. So anything under our target of 85%, right? They look at this week here and they say, oh, well, we'll do our training here. And then our training happens and wow, look at this. So they look and they say, well, why are these weeks low, right? What can we do? What are we doing wrong? And this is kind of what happens at companies because, we're all pattern thinking people and we're trying to do this data work, but it really, when we understand variation, we understand why this type of thing doesn't work. So here, the fix is in, right? Basically, what we did is we generated a whole bunch of random numbers here, and we made sure that the target, it would hit that average target of 85%. And so the thing is, this is all random noise. And so if we understand variation, we understand that surveys themselves are suspect to a high degree of variation because, one person's 7 is another person's 4, right? If we understand all that, then we aren't really surprised and we aren't just trying to chase week to week. It's just kind of like here people do a lot of NFL fantasy football, right? And so they think that the performance that maybe happens last week is going to predict the performance next week, but there can be a high degree of variation in that. So just if we understand that, right, we won't be chasing these elusive metrics for things that don't make sense. And where should we expect variation? Well, the answer is everywhere. And in particular, small data can lead to extreme variation. So in this chart over here we have on the right, this comes from a news article. See, I always forget where it comes from. Alex, if you could help me out on that. It comes from the Scientific
American.
Okay.
Yes.
Yeah. So it comes from a news article, and
sorry.
It's the most dangerous equation, right? Is that, if I'm saying that right?
That's the name of the article. Yes, the most dangerous equation.
And the reason why it's the most dangerous equation is because, right, if we look at this chart over here, we see that for populations that have or for smaller populations, the cancer rates can vary wildly. And so if you look at these different cities here, right, if you look at different cities here, you might be comparing them, trying to figure out, well, why are they so wildly different? And so when you look at it, you can see cities right next to each other that have the same stats. And the answer that they're so wildly different is not because of things that the cities are doing themselves, but rather because they're small populations, which gives way to extreme variation. And if you were the New York Times doing COVID analysis, what they do is actually, cities and towns that are less than a certain population, they actually change their metrics to account for that. So this is, in their case, they are being data heads. All right, so, we think that sometimes we think intuitively, or our intuition matches our sense of probability. We've all heard it before. 80% of dentists recommend this certain toothpaste, right? So this is what commercials use. And so 5 dentists are sitting in front of you now. What is the probability that 4 out of 5 recommend them? So I'm going to just give you the answer here. The answer is 41%. And that doesn't necessarily match our notion of what 80% of all dentists recommend. So in doing that, right, in sort of casting it this way is what marketing often does. In casting it that way, it kind of leads us astray. So once we understand that we can't always intuit probabilities very well, we are left with the idea that we should come to the statistics and see what they say. All right, so this one, you can hit the chat if you'd like. Just following our theme, Sam is 29 years old, reserved and bright, majored in economics at Wake Forest University, which is in North Carolina. Volunteered to tutor students in statistics and loves Python. Okay, so which one of these is more probable? Sam lives in North Carolina, or Sam lives in North Carolina and works as a data scientist? And go ahead and hit the chat with a 1 or a 2.
Yeah, just make sure you change the drop down to everyone rather than just hosts and panelists. So most people saying 1, it looks like, yeah.
That's right. And so maybe they know this, because I have to say that as we were writing this, I was like, are you sure? To Alex, no, I hadn't heard this before, but I can see why people would pick 2. The answer is 1, of course, because the probability of 2 things happening is always going to be less than 1 thing, right? So as you add on more probabilities, the likelihood of that happening is always going to be less. And so this is really important to know. I presented this to a group, or I presented this to, I think it was a group of analysts recently this week, and some folks had said there's not enough information, like it's a GMAT problem. And so, there is in fact enough information here, but it's something that we don't often think about in our work. All right, so with that, I'm going to actually hand it over to Alex to take it over from here.
Yeah, thanks, Jordan. So the theme that we wrote the book about it, and we're admittedly trying to rush through it here in an hour talk, is to maintain a healthy skepticism when working with data. And the other is that you don't need to be intimidated by the mathematics, is that as long as you have this healthy skepticism and some statistical thinking, those data detective skills, that you might be able to think and understand what's going on and ask intelligent questions. We also like to talk about common pitfalls. So one common error is that we see a lot, and this goes back to even the financial collapse, is multiplying probabilities endlessly. So there's this famous case where Sally Clark, she was a mother, and 2 of her children tragically died of sudden infant death syndrome, which is known as SIDS. This is a case out of the UK. And the prosecution came back and said, the chance of one child dying is 1 out of 8,500. So the chance of 2 kids dying is 1 in 73 million. So based on this, multiplying these two probabilities, and as you multiply probabilities, the numbers always get smaller. It was deemed like, well, that's 1 in 73 million. Obviously, something nefarious was going on, and she was guilty. She was tried and found guilty. But Jordan, if you build on the slide, please. This is known as the Prosecutors Fallacy. Just do the space bar.
Oh, 1 second. There we go. I got it.
This has some faulty statistical reasoning. It was because probabilities are conditional. So the chance that 1 kid dies, it would be, the fact that 2 children die from the same parent, maybe they have the same underlying conditions. So you should not just multiply these 2 probabilities back to back. The chance of this happening by random chance alone would be much smaller than that 1 in 73 million chance. Spacebar again, please. So they call this the Prosecutors Fallacy.
There we go. I got it.
Yeah, keep going.
All right.
She was later released. The Royal Statistical Society of the UK intervened. And it's called the Prosecutor Fallacy because by multiplying these events endlessly, you can make anything seem impossible. I see a comment, lawyerly math. That's exactly right. Because you could think about, like, what is the probability that someone from Troy, Ohio, partnered with someone from New York City. I'm in a population of 1 out of 25,000. Jordan's in a population of 1 out of 8 million, got together and wrote a book. Well, it's surely impossible. So this is a common error that you can kind of use to just be aware of that people do it when something seems overly impossible. And multiplying probabilities, they make it seem like in the other case, sometimes people make like the financial collapse. Oh, that's going to be impossible because all these people can't default on their loans at the same time, right? But no, when there's a recession, one person's the value of my home would drop. That means the value of my neighbor's home would drop, preventing them from refinancing, and then it all falls down like dominoes. So this ability to think statistically is really important. Next slide, please. And in this part, we want to pivot a little bit to machine learning. And we're kind of bouncing through topics quickly here, but our book's about data science, statistics, and machine learning. And machine learning has so much hype. If you're a financial modeler, I'm sure you can find financial modeling or machine learning with financial models. There's courses online. There's still a lot of confusion about it. So the next few slides are just, even if you don't understand the math, how you can ask questions and kind of understand what's going on behind the scenes. So when I'm talking about supervised learning, when I'm talking about machine learning, most of the time it's actually a type of machine learning called supervised learning, where you have historical data, where you have inputs and outputs. You can imagine this Excel spreadsheet like you have here, where you're trying to predict the target of something in the future. So you take historical data, you run it through an algorithm. And in that bucket with the gears, that's where you hear a lot of the technical terms in machine learning. That's where deep learning falls, XGBoost, random forest, all the math, where a lot of people get intimidated is where those gears happen. But what comes out of that is a model that is used for predictions. We have a new input that predicts an output. And on the next slide, we have several examples that we mention how supervised learning is everywhere. It's the spam detector on your email. It learned when everyone first had Hotmail or Gmail and you said, this email offering me free medicine is spam, that went into a database where an algorithm later learned to associate certain words with spam or not spam. Real estate, Zillow is a popular website in the US. I'm not sure if it is in Australia, but It predicts the value of your home built on a historical sales price. Facial detection, smart speakers, these are all cases of this input to output relationship. And it's all really exciting and it's interesting work. And it almost does seem like it's science fiction, but behind the scenes, there is so much data collected. And that's where, when you call someone a data head, it's the ability to argue and understand that process of machine learning. Because if machine learning is the sexiest new job of the century, the unsexiest job would be collecting data for machine learning. So if you go on the next slide, Jordan, I'm sure we've all seen these captchas where you're going in and if you want to buy tickets to a show, it'll say, prove you're a human. So you click, okay, here are the squares that contain a stop sign. Well, these are used to train self-driving cars. This is the data that's being collected. So the joke that we say in the book is don't get into a self-driving car until they stop asking you what a stop sign looks like, right? If a computer can't figure that out, then we're in trouble. But these are getting harder.
That's very true. Yes, that's scary.
Yes. Now they're getting harder where it's, I had to do one the other day to pick out 6 chimneys on these blurry pictures. But my point is, our point in having this slide is that companies have been collecting this for years. So if you work for a company, as I have, and everyone wants to just make an immediate impact in machine learning, we're not all starting from the same. We're not starting from the same starting line as these big tech companies who have been collecting this type of data for years. The other example on this slide is the old captchas to prove you're a human were to do the text. Computers have figured this out. This has gotten too easy, which is why we switched to images. These were used to digitize books on Google, by the way, when they scan images. And now when you go on Google online for old text, you'd see, you could see, okay, that's an F, then O, L, L, A, R, et cetera. So it's really about the underlying data. And if you go to the next slide, we have a chapter called Arguing with the Data. And this is something you can do as a data head, whether or not you're familiar with statistics or modeling, because everything grows from the data. If you're a chef, everything's going to come from the ingredients. If you have bad ingredients, it doesn't matter if you're a master chef, the meal is going to be terrible. If you have bad data, it doesn't matter if you're a terrific machine learning engineer, data scientist, your model is going to be garbage. Garbage in, garbage out is is a common saying. So when you think about projects and claims that people are making with your data, whether it's financial or any type of scenario, you want to think, how is this data collected? Right? What is its origin story? Is the data representing what it should represent? And what data am I not seeing? There have been several data disasters where you think you have the entire picture, but not everything is encoded as data. So in the next few slides, we'll walk through some examples of pitfalls that could have been identified if people kind of argued with the data and thought about it a little bit. So this is an example. This is an older article in 2014, I believe, when big data was all the rage, if we've heard of big data. Now it's all AI. But in the city of Boston, people were told to download an app on their phone. And then when they were driving and they had the app on, if they hit a pothole, the phone would flip and the city would be like, great, here's a pothole. So they had this map of all these potholes all over the city. And it was like, hey, this is a big data success story. But they realized quickly, again, this is like 2014, they were only filling potholes in wealthy neighborhoods. Because if you think how the data is collected, it is through a device that costs hundreds of dollars. This is before smartphones were very prolific. There's just this bias in the data where you have just this missing data where not a lot of people are being serviced. And on the next slide, there's a book that talks about some of these data, the biases in data. One story that was interesting was in Amazon, and this was an article from 2008, you can see the date there, where they had this recruiting tool where, if you see the quote, everyone wanted this holy grail. They wanted an engine where you could give it 100 resumes and it'll spit out the top 5 candidates. But if you think about how this data behind the scenes, right? You see this, if Amazon said it has an AI recruiting tool, and you could apply this to whatever your use case may be in financial modeling, we're using deep learning, natural language processing. As soon as those terms come out, some of us who haven't been trained we just kind of sit silent. Like, well, I don't know enough about machine learning, NLP to ask questions. But if you think about the data underneath, Amazon and tech companies traditionally have hired men, but more men have gone into the field. So when you look at the historical resumes, out of 100 resumes, you may have 70% that are from males, 30% that are females. So if you build a classifier on that just by itself, any word search is going to pick up words associated with males. So just being named Steve gave you a boost. Obviously, that's wrong, and that's potential bias. But that is a separate piece from understanding natural language processing or deep learning. So next slide, please. Another type of bias when you think about data would be, we'll say data that's somewhat scrubbed. Many of us, if we've ever looked at data, we see outliers. There's always that decision. Am I going to get rid of this outlier or am I going to keep it? We may have horror stories where we've seen someone throw away an outlier because if we throw it away, it gives us the answer that everybody wants. But really, you should only throw away outliers if there's a non-statistical reason for it. Like it was a legit mistake. It kind of related that is this idea of survivorship bias, where we only look at the winning data points. Now, Jordan is a visualization guru, and I know he hates this visual. He did not create it. But if you look at some of these blue lines, this is representing mutual funds. So if I'm a mutual fund manager, Danielle is, and Jordan is, we could each pick a handful of stocks. And just by random chance alone, one of us is going to beat an index fund, the statistical an index, like the S&P 500 or whatever the equivalent might be in Australia. So let's say Danielle wins, then Jordan and I may quietly shut down our funds. So that way, if you go to look back, the three of us, we have a great track record of beating the stock market. So the tallest blue line is saying over 5 years, 60% of funds were beating the S&P 500, which is the index in the United States. But if you included all of those ones that they stopped, it drops to under 50%. So at that point, you're better off just going with the index fund. Now, the quote that really summarizes this, if you could do the build, please. Shouldn't be able to rewrite history. Your grade point average would look a lot different if you took out all of your failing grades. But that's what a lot of these companies are doing. And this is, our book, like I've said, is general, but we tried to think for a financial audience. This one, it may be a story everyone has heard before. But that's, so you want to think about the data that you're currently analyzing and maybe what data was left off. Next slide. Another concept that honestly, this was never, so I'm a trained statistician. I went through graduate school in math and then statistics. This was a practical problem. I didn't see this until I was working in industry. This is not covered in a lot of textbooks, this idea of leakage, which is when you're kind of cheating. So I'll just kind of walk through this. This is a famous example that I tweaked a little bit, but there was this company who was trying to predict the stock market for the next 5 days. And someone made an algorithm and they improved the performance by 20%, which is huge. That'd be huge for any financial modeler. So when they did back testing, and back testing is when, today is, for me, is September 28th. Like I'll pretend it's August 28th. How well would I have done the following week? Well, eventually they figured out is that every week's prediction, so if it's Friday and I'm predicting next Monday through Friday, that the actual Monday value was included in that prediction. And there is no scenario in the world where it's Friday and you're placing bets for the stock market next week where someone tells you, by the way, Monday's sales price is going to be X for all these stocks. So 1 out of 5 days, that's how they got that 20% improvement. This happens in supervised learning problems. So I work in, my previous job was in retail, and we've had some models where we're predicting if somebody's going to use a coupon. If you know the coupon redemption value, then it's, if you know when the coupon was redeemed, then yes, it's very easy to predict, was it redeemed or not? Now that's like an extreme case, but the idea of leakage is you can't use data that you won't see at prediction time. Next slide, please. We just have a few more slides. A big one that would impact whether financial models or retail, and we all just lived through it, we're still living through it with the pandemic. The data it has to be historical looking, right? We're using historical data to try to predict something about the future. But when something as impactful as a pandemic hits, nothing in our historical data could have predicted some of these retail models or crazy swings in the financial markets. Like no one would predict in the United States that everyone would start stockpiling toilet paper. There was nothing that was like that. So if anyone on the call works in industry, you would have quickly realized that any model you had that you built from data prior to March of 2020, that's when it really hit the US, maybe sooner for Australia, all those models were useless. So companies are still trying to figure out what is this new normal? Because if you make a model today to predict financial markets next week, I mean, is it still going to be relevant? But these are things you can kind of think about as you're arguing with your data. Next slide, please. This was a slide, kind of going back to thinking about machine learning and historical data. One thing that we communicate when we have a lesson on deep learning is that to a computer, everything is numbers. And that's something I think we often forget, as strange as that is, right? We as humans assign meaning to a data. We give it a narrative, as Jordan said, with the illusion of quantification. We give it a story because we're pattern-seeking individuals. To a computer, it's just a block of numbers. And this is a case where to a computer, the stop sign, it's a block of numbers until you put these little stickers on it that say love and hate. And now it's no longer a stop sign. So this is obviously would have an impact for self-driving cars. Now, luckily, they have radar and LiDAR to help out and GPS. But the point is that these algorithms can be fooled. One case I saw that this gentleman he was worried about facial detection, so he bought a jacket and it had faces all over. So whenever he would walk in, like it would flash all these faces on him. So that this is going to be a challenge with AI. This also gets into privacy, and I see there's a question about anti-discrimination laws with AI. There are some legal challenges with AI. If you can go to the next slide, please. And when I say AI, when Jordan says AI, what most people mean is machine learning. There is a very rich field of artificial intelligence. People have been studying it for years, but the hype of AI that we hear now is machine learning. And I think that's important because it's not intelligent. It's very narrow use cases built on historical data. And if you can argue with the data and understand that it's built on curated data sets, you have a better understanding than most people about AI. You don't need to worry about pending doom or anything like that. But we do have to worry about people over relying on these intelligent, in quotes, systems. This was a recent article where someone was wrongfully arrested over a false facial recognition match. I'm not sure of the legal ramifications of this to get to the questions, but it's these type of questions we need to think about. How much do we want to put trust into these algorithms to make our decisions for us when a lot of people who influence these policies don't really understand what they're doing? They don't understand how, they're not data heads. So maybe every city and everyone will buy our book so they won't make these decisions, or at least make them smarter. So next slide, Jordan. These are just some references if anyone's interested. There was a comment, a lot of statistics books, one that I would recommend. Here are a handful. So if anyone's interested in learning statistics, it really depends if you want to learn a formal statistics class, or, in the case of our book, it's kind of a conversational statistical understanding. But here are several books that we really like. These aren't traditional textbooks, but they're all of the same vein. How do you think statistically? A lot of the lessons are statistics gone wrong, where people misapply them, as we've done here, because those are the ones that stick. Like, those are the ones that get people to be aware of, like, hey, I need to pay attention from now on. So with that, we will open it up for questions. We can take deeper dives into any segments. I know we touched on a lot of things, but happy to take questions.
Yeah, I can see there's quite a few comments and questions coming in. If you guys want to have a look at some of those and pick out some of the questions that you'd like to respond to. There was one actually back when you were talking about the Prosecutors Fallacy example. Clinton wanted to know what the math would look like if it wasn't multiplied.
I mean, there would still be some multiplication involved. It would be with conditional probability. The challenge of that case would be to find out, kind of what's the overlap. What are well, first of all, there need to be some other medical studies to figure out.
Yeah, so not a simple answer, yeah.
Yeah, multiplication would be in there, but it would not be a simple answer. But just with probabilities in general, many times you have to multiply probabilities, but there are other parts of that equation that actually make the probabilities quite different than what you would expect initially. Probabilities are not very intuitive in general. People kind of overestimate their affinity to understand probabilities.
And that's something that a lot of financial modelers need to include. Often the assumptions that you're putting into your financial model are reliant on these statistical concepts like probabilities, and it's something that we are naturally, as you say, not very good at. So I think it's important for modelers to understand the basics of probability. So was there any other questions you wanted to address that you can see in there? If there's anything else, guys, you'd like to mention that you want Alex and Jordan to address, just pop it onto the chat. I got to say, I don't know if you realized it, you mentioned it was the 28th of September. Yeah, today's the 29th. It's 9 a.m. here in Australia. So we are coming to you from the future.
That's right.
Yes.
Yes, it always makes me laugh when I do training and we do the today, you do the today bracket, open bracket, close bracket function that gives you today's date. And very often the date that's showing on my Excel is different to other parts of the world. So something to consider. Yes, it is the 28th in many parts of the world. Where is a good place to start learning machine learning? We have a question from Augustine.
To learn it as a practitioner, the general place I recommend is Kaggle. Kaggle, which was started by an Australian, actually, Anthony Goldblum. It's now owned by Google. But they have web-based platforms where you can code in R and Python. And they have micro tutorials. So that's a great place to start to learn to be a practitioner. If you're looking for an understanding, like a conceptual understanding, then becoming a data head, that's one of the reasons why we wanted to write it, because not everyone wanted to program like deep learning, but just like, kind of give me a working knowledge of how deep learning works.
I would say, I kind of think that, Udemy, I love Udemy. And I think that, if it all really depends on where you want to go with it. If you're just dipping your toe in it, then Udemy is a great place to start from a programming perspective, if that's what you would like to do, like from the programming side. But as Alex said, machine learning is a huge field. Many of us just have the imagination for like the engineers who are coding them up. But there's still project managers, there's still product people who have to manage the results of that and have to understand what's going on. So you have to kind of figure out where you want to be, within that ecosystem and go from there. Yeah.
I talk with a lot of students, undergrad and graduate, and the one advice I gave them last time is you don't want to fall into analysis paralysis, because there's Udemy, edX, Coursera, Udacity, there's so many. And there's so many books. The best thing is just pick one, get all the way through it, even if it's not, and then, after that, you'll have kind of a foundation to go through another example. And then before, you'll realize what resources are maybe redundant or what's kind of increasing your knowledge.
We're getting a couple of good comments, good recommendations in the chat, which is helpful. Someone's asked about the data science bootcamp. Is it worth it or unnecessary? I'm not familiar with that. Is that something you guys know about?
I think we could speak to that. There's multiple data science boot camps. I'm like of two minds on this, because on the one hand, there's a world in which it is totally unnecessary, right? Because you could go out and learn these things on your own, but you have to kind of be honest with yourself whether you're going to do that. There's another world in which you say, I want to do research. So in that case, a master's degree or something more like that would be better. Now, some of these boot camps are designed to take smart people who have like quant, finance, numeric backgrounds and bring them through the boot camp and then place them somewhere. And then the boot camp gets money. And so it's called a fellowship, right? Because they basically take you through for free. Now, if you get accepted to one of those, that might be worth it because they have really good relationships in terms of getting a job. But I think you have to think about what your end goal is going to be, because at the same time, I think there's a lot of boot camps out there that are probably are too general for exactly what like your ideal job might want.
Yeah, it depends whether it's going to be just part of your job or whether it's going to be a whole job. It's a very different way to work. And I think that for most people, it's just like financial modeling. Financial modeling is a great skill to have that perhaps would be part of your role. And similarly with data science, it's good to have that sort of background and understanding, but it may not be, you may not call yourself a data scientist, but they're fantastic skills to have as part of your skill set. So it's definitely something that you should consider learning.
What, Alex, do you have any thoughts? Oh, sorry.
Oh, on the boot camp. Yeah. So in the US, at companies where I've worked, I don't know if a boot camp has not been given as much of a preference as like a master's or even an undergraduate degree, since students are coming out with undergraduate degrees in data science. However, I'm never going to discourage anyone from learning more. I've taken many like Coursera certificates myself, just because when I was going through grad school, I didn't have a deep learning class. So any individual boot camp, I listen to Jordan, track down what their placement is. If that's the end goal, but if the goal is just to learn, then, I think they're great. There may be cheaper ways to do it, but I'm never going to tell anyone not to learn. So
there is that EDX site, which is like Coursera, that has certificates that you can do online and has boot camps, but you can also just try the classes out and decide if they're for you,
Yeah. I did see a question on tips on practicing on predicting with limited data. Whoever asked that question, I can't see the name, but could you, I'm curious if you have a number in mind, because I gave a talk last week about statistics versus machine learning. And statisticians have been using limited data for years. My dissertation was on how to collect the best limited data. But the degree of limiting can vary. So if you're on a machine learning algorithm like flowchart and you want to predict it, one of them says scikit-learn in Python is one of the most famous machine learning libraries. And it said if you have under 50 data points, get more data. But that's not always true, because I worked in design of experiments where you turn knobs on a machine, you get data. We may have as few as 8. It just matters if the data that you're collecting, you want to make sure that it's not correlated. It all depends. If your data is clean, you can get by with fewer data points. Clean meaning uncorrelated.
And so, in thinking about, like, I know no one really asked this, but I'm just going to throw this out there. There's a lot of questions about what are the technologies you should use for data science, right? So I think that Excel gets like a very bad reputation for not being powerful enough. But a lot of people who make that claim are not, they still are like seeing Excel as the 2013 version, not seeing a lot of the new stuff that's come out for it. So, there's a lot of tools and technologies, things like Power Query in Excel. And I only bring that up because there's dplyr in R, in pandas and Python, and those things actually do what you can do. They basically do the same thing as Power Query does in Excel. They're all very related technologies. So I did mention Excel. I don't think VBA, I love VBA. I don't think that has much future, to be honest, in data science. But I definitely think people ask R, Python, and Alex can give his opinion on this. I definitely think Python is the future, even though I'm an R person.
I've been chatting privately to some of the participants.
Yeah, I know. I want to hear what your thoughts are on that.
On R and Python?
Or no, on the private chat to the.
Which one?
Sorry. I don't know. Sorry, I'll let you say your thing.
Just tell us.
Yeah.
On the R and Python debate, I say pick one really well and learn the other also. Learn one really well, but also learn the other.
Just for my 2 cents worth, I think Microsoft's working really hard to keep Excel relevant in space of machine learning, AI, all of that stuff. It is something that you often. Shouldn't discount that if that's what you need, rather than jumping out. And it's great to learn the other ones as well, but don't discount Excel.
Yes, sorry, I did not mean to discount Excel.
I
still use Excel.
Yeah.
It's fine. I'm used to it. No, a lot of people. I think Excel has more to prove to be a data science platform. And then I think also Power BI and Tableau are two very interesting platforms. People ask what the difference is, and they're really, it's like the difference between two different, cars from two different makers, they're very comparable. But if you live in a Microsoft ecosystem, Power BI would be the way to go. Power BI and Tableau do not allow for data security. I see, I don't know about Tableau. The security in Power BI is very rudimentary. It allows for row level security, but not much else. It's pretty, someone called it convoluted in my last class as I was showing it. I was like, yes, that's true. I do think that's a fair statement.
So there's another question in the Q&A. What are your thoughts on human machine learning collaboration versus using machine learning alone? Sometimes that's called human in the loop. And many of the machine learning applications I've been a part of in industry have had humans in the loop because of some of the problems that we were talking through today. And I see comments online about the risks with ML. Machine learning is still very powerful. people, even today we pointed out the flaws, but it's really great at solving a lot of problems. And I think it can be benefited when there's a human in the loop. So if you're doing a classifier, I think Uber did this where, where people had a question going through customer comments. If they could easily predict what the comment was and how to respond, if the prediction was really high, say 0.8 or above, it would just do the automated response. But it was tiered. If it wasn't, they get a human in the loop. If nothing knew what's going on, they get a phone call. And that's how companies are starting to do their first pass at a lot of these machine learning applications. Another question on C# for data visualizations. I've never used C#, so I apologize.
I was trying to think. I was trying to think on that too, because I used to program in C#. You know about the programmer who couldn't C#, right? Sorry.
Yeah.
But yeah, no, I'm just thinking if the only ones I really know are D3 for JavaScript, and then of course matplotlib for Python, and ggplot for R.
There's a good one here from Lyle on your thoughts on RPA, robotic process automation versus Excel macros.
Wait, say that again. Robotic process automation.
RPA versus Excel macros.
I don't know. I mean, are those two things? I don't know what RPA is. I don't. But
robotic process automation.
I don't know what that is.
I think it's just generally, using other tools versus using macros. You did sort of mention that VBA is still there, it's still hanging in there, but I don't think it's got a huge future. Paul says VBA macros are more DIY algorithms. I guess. All right, we're trying to. I got the giggles after that D flat joke. So any other things you guys would like to? I think we're just about out of time. So was there anything else that you guys would like to address? Anything that we missed before we sign off for today?
Well, can I think I have my new course here that I would love to show the folks.
Tell us about it.
All right, so you can go to, and I'm going to put this in the chat, advancedexcel.com. So it's Advanced XL, and I'll just show my screen real quick. We had a slide for it.
Great. And I'll pop a link in I'm going to send out an email to everyone who registered with the recording, and I'll pop a link to that as well.
Sure, it's certainly, and I appreciate that. But so just if you're wondering what this course is about, it really, this is like the top of the website that I just screen capture, but I really just designed it for people who consider themselves intermediate Excel users. So, there's a whole beginner, intermediate, expert thing with Excel. And the problem with these courses is they're all really for beginners, right? They're all about helping someone who has no experience in Excel get better at Excel. So even the expert version is still a beginner level course. So this is designed for people who use Excel every day. Someone said they live in Excel. It covers all my greatest hits: data visualization, dashboards, interactive dashboards, and Power Query, and then some new stuff on Power BI and DAX. And then finally, there's a bonus part in it where I do like 3 really advanced dashboards in Excel. So it's really my best stuff. And it's $297. You can go to advancedexcel.com and learn more.
Fantastic! Thank you so much for sharing that, and thank you so much for coming with us, joining us, and taking me through all of this. Fantastic! I think the financial modelling community really appreciates what you've shared with us today.
Thank you for having us.
Yes, thank you.
All right, thanks, guys. See everyone.